A force of 6 kilograms is in equilibrium on a rough horizontal table. It is connected by a horizontal light extensible strings over smooth pulleys to particles of mass 2m kilograms and 3m kilograms which hang freely, as shown in the diagram. Find the frictional force on the block indicating clearly its direction. So we've got this sort of diagram. So what we need to do is we need to draw that out and draw the forces on it. Okay, so if we consider this block here, we have its weight acting downwards, and then we have the tension in the string here acting upwards. We're going to call that T1. Then this one will also be T1, and then the forces acting on this block will be that T1 plus its weight acting downwards, 6mg, and then the resultant force of it resting on the table. And then also we have a tension T2 acting this way, and we have the resistance. Because this weight is heavier than this one, but it's in equilibrium, it will have a tendency to move this way. So this frictional force is actually keeping it in place, and this is what we've got to be able to find. Then going to the third block, we've got the tension T2 acting upwards, and the weight of that block acting downwards. What's important is that this tension is different to this tension. Right, now if we now resolve each block separately, so we'll do the 2 kilogram block, remembering the system's in equilibrium. So this is going to have a tendency to move this way, so it's going to be T1 minus 2mg, and it's going to be equal to 0 because it's in equilibrium. This one we're going to have T2 minus T1 minus this frictional force here, and that's going to be equal to 0. And then for this one, we're going to, because it's going out this way, it'll be 3mg minus T2 is equal to 0. All right, because it's not moving, it's in equilibrium, and this frictional force is keeping it in position. So if we label those 1, 2, and 3, now the simplest way to solve these is just to add them. So if we add 1 plus 2 plus 3, if we do that, we're going to get T1 plus minus T1, so they cancel out, and then we're going to have T2 plus minus T2, they cancel out. So we're going to have 3mg minus 2mg, which just gives me mg, minus that F there is equal to 0, which gives me that the frictional force has to be equal to mass times g newtons in the direction shown in the diagram. So the frictional force here will be mg newtons. So this has been a video to show you how to find a frictional force of a connected object. I hope you've understood, and I thank you very much for watching.